Heating up!
Part 2.
He's on fire!
Hello everyone, Sharp here. Today we're going to be talking about the parts of a thermometer. Now, first thing we need to know is the reservoir and the capillary. Now that's what contains the red liquid here, and it goes all the way up the scale here, and it is in a vacuum. Now what's a vacuum? Vacuum means that the only thing that they have in this whole tube is that red liquid, nothing else, no air, nothing like that. And why is that? Because if there was air in this, that would have an impact on the temperature, and it could give you a reading that is not entirely correct, and it will impact the expansion and contraction of the red liquid that's in this. Okay, next thing we're going to talk about is this red liquid in here. Now, this is an alcohol-based solution because we used to use mercury, but mercury is poisonous to humans, so whenever anyone would want to find out what the temperature is, they'd die of mercury poisoning.
What?
I'm just kidding, that's not true. Or is it? It's not, but it could be. It's not. Is it? Anyway, so we have a red alcohol-based solution that expands and contracts within this reservoir and capillary scale, and that's what tells us the temperature. Okay, next thing we're going to talk about is the glass itself. So it's hard to notice, maybe if I bring it a bit closer. So if you see right here, it's kind of thin. We have thin glass right here. Then you can see the capillary tube where the liquid is going up, and the glass is a bit thicker in around here. Now, why is that? The reason is because if we want to tell the temperature from this reservoir, we want the outside factors to have an impact on what's going on down there, and then we don't want it to have an impact on the thicker glass that's around the capillary tube. So not only do outside factors not have as strong as an impact on the capillary tube, but it kind of gives it a bit more protection. Here we have, you see a bunch of brown lines, and I'm going to bring it a bit closer as well. Now, can you see that? Maybe, maybe not. If I could get any sort of indication from someone behind the camera, okay, there you go. So you can see that. You can see that there are these brown lines and numbers and stuff. So that's the scale. Now, temperature can be measured in Celsius, Fahrenheit, and even Kelvin. Now, we don't really use Kelvin a whole lot, but it can still denote temperature. But this scale is Celsius. So if you look at this, I can see here that there are a bunch of marks along the way that go up by ones. So right now, that number 20, I'll hold it there next to the 20, and maybe you can see that. So you see the 20, and then it's 1, 2, so it's 2 more marks above the 20, okay? So that tells us it's 22 degrees. All right, now, if you can look right here, I mean, you probably can't see it, but there's also a mark that says 0. Then there's a 10 below the 0 and a 20 below the 0. That means we're in the negative temperatures, okay? So wherever this ends up, that red mark, or how high the liquid goes up or expands inside the capillary tube, wherever it stops, you can tell the temperature based on that. Finally here, now these thermometers are pretty fragile. They'll break easily. No, I'm not gonna show you how they break. But if you look at the top here, there's a little hole where you can put a string through. So if you need to hang it from a place without having to touch the glass itself. Also, there's a piece of rubber here, and that's used for, you can use it for a few different things. You can mark changes in temperature. If you want to say, what's the temperature here, put a mark on, and then go outside and say, where's the other temperature, and then say, oh, there's a difference of however many degrees. The other thing is that if you're clamping it on a stand, you can clamp the metal part to this piece of rubber. That way you're protecting the glass itself, and then you can still have something secured, okay? And that's the parts of a thermometer. This is a phone.